can do the revision. For solar it is the 8 times, and wind it is the 16 times. And every 1 hour 30 minutes you can do the revision, but there is a tweak. Okay, when you give the revision after 2 hours, SLDC will consider your revision. And obviously the error formula is changed here, and there is a no penalty error, no penalty zone. Basically, you don't have to give penalty if your scheduling or the projected forecast is in plus minus 15%. Though it is changed from state to state. In Tamil Nadu, it is plus minus 5% for the solar power generation, and in case of Gujarat, it is plus minus 10% of the solar power generation. So when to forecast? First time is yearly for the long-term project planning and all these things. Even we do forecast for the next 20 or 25 years for different project of the banking, refinancing, all these things. That's separate. But in this case, what we need, it is a day-ahead forecast and the revision in every 1 or 6 hours. So forecast time block, according to the Indian regulation, the forecast time block is a 15-minute time block. So 24 hours and 15 minutes is the 96 time blocks total. So you have to forecast basically 96 data point ahead at any given time. The regulation says that today at morning 10 o'clock you have to give the forecast of next day, and you can give the revision every 1 hour 30 minutes starting from today 12 o'clock. So actually basically you are forecasting 96 time block plus morning 10 o'clock to 12 o'clock. So that is the extra time period you have to make such any other revision. So basically one data point is the how much kilowatt hour in 15 minutes, or you can say what is the average power in this 15 minutes. So basically the forecast horizon is for 1 hour is 4 time block, day ahead is the 96 time block, weekly is 672 time block, and monthly is 2880 time block. So when you are calculating the total monthly penalty, the SLDC will calculate on 2880 time block what is your plus minus and what is your forecast is under no penalty zone or it is beyond your penalty zone, and they will calculate total penalty, and they will produce a bill in every 3 months. That is the strategy. There is a one tweak in case of solar. In some IPPs, which are working with the SECI, they are charging nearly 3,000 rupees in per revision. So though in the regulation it is stated that 8 number of regulation is feasible, but this number of revision, 8 times revision, not all time free. Because for other energy sources, hydro, coal, the scheduling charge is nearly 3,000 rupees. And it is a one good example. MP SMDC is charging nearly 3,000 rupees per division in case of solar also. So if you are thinking that I will revise 8 times for giving a good forecast, it is not a good strategy. So you say that do your forecast, maintain the best accuracy in minimum revision. Because in future, probably like MPSLDC and the draft regulation of the PSLDC, the revision charge may apply to the forecast generation for the different IPPs. Obviously, what to forecast? The question is that you can forecast in the PV or the turbine level in case of wind. In case of plant level, same IPPs. Or if you have the different IPPs in the same pooling station, you can aggregate the forecast, and basically de-pooling their penalty charges. That is a different work of QC and all these things that is written in the regulation. Though the boundary and the limit of QC is not properly defined in any regulation in India. And another thing is the aggregated level, which is much more useful for the SLDC and RANCs. So basically, it is approximately a tree structure. At any node, you can do the forecasting. Forecast error, that is a good thing to measure the accuracy of anyone's forecast. One thing is that if you see any other documents in DEL or any other documents, the forecast accuracy they say using root mean error square or the mean absolute error, etc. In case of Indian regulation, it is totally changed. They said it is the point regulation. That is that at each and every time block they will calculate the accuracy, and at that time block, if it is plus minus 15% or plus minus 10%, if it is not there, they will put some penalty on you. So using the norm of different error definition, okay, you can calculate your forecast accuracy. Just 1 minus normalized of the mean absolute error and 1 minus normalized of the root of mean error square, etc. The thing is that how you choose one forecasting service provider. The best thing is that you just ask them what is your accuracy in coming in plus minus 15% or plus minus 10%. What is the probability? That is how many number of times it is in, how many number out of 96 time blocks, how many number of times it is in plus minus 10 or plus minus 30%. Then you simply calculate your value here. Okay, so it is the average cost of penalty what IPP will get. That's a simple relation. Okay, we are not providing any proof on it. It is there in our website. Okay, if you wish, you can send that. So just like it is, I'm coming to solar. Okay, just like that. Okay, you just ask what is your probability in plus minus 15%, plus minus 15 to plus minus 25%, and you calculate your probability. What is your penalty? Average penalty per unit megawatt generation or per unit kilowatt generation. And depending on that, you calculate accuracy, because see, technical accuracy we can say anything. Okay. But from the IPP's point of view, okay, they will simply ask what is the penalty, how much penalty, and what is the penalty, the percentage of revenue. They will not ask anything about what is my root mean square error, what is my percent, how many times it is in plus minus 96, plus minus 15% in 96 time blocks. They will simply ask, right, what is my penalty I am paying in 10 megawatt or 100 megawatt solar plant, and what is my percentage of, as a percentage of revenue. So when we are talking about the forecast, what are limitation of a forecast model? What is the model? It itself has a limitation. Okay, no model is perfect. We are not God. We are make some statistical model. We make usable model, and those usable model give some result, and we say that okay, it is acceptable, but no model is perfect. There is a problem of chaos. You see, in most of the model, they much more dependent on numerical weather prediction model and all these things. That is we call it NWP. But there is a problem of NWP. Most of the NWP models are basically some differential equation, and you know that any differential equation, the biggest problem is the initial value problem. How you choose your initial value, that is a big question. And due to the choice of the initial value, there may affect the chaotic condition in your model. That is the chaos. And another is the data and data analysis uncertainty. Most of the time we get data from the SCADA and all these things. Okay, and in practical sense I am saying, okay, so in 1 hour you will not get any data from the SCADA directly. There is no data, but you have to forecast. So you don't have any data in the 10 minutes. You have to make some statistical interpolation or anything. Okay, and you have to basically with some probability you say, okay, my output is like that. So there is also a limitation. The question comes, who is responsible for the low accuracy and false precision? Power generators, if they don't say the actual available capacity value to any forecasting provider, if the power generator does not share their data on scheduling to the forecasting service provider, and forecasting service provider, if they produce some fake precision, and it is well known, lots of people give fake precision or the false precision, because when you calculate in 2880 block, and if in some block you make some false precision, nobody will understand, but it happens. Another thing is that it is a computational expensive process, any forecasting process. So if it is below some certain level of accuracy, the power generators may charge the forecasting service provider some penalty on it, because the service provider producing the forecasting for the IPPs, and IPPs has a right to charge penalty on forecasting service provider. How to forecast? Basic three method. One is that the persistence result, that is the old school philosophy. What we have today, we will produce the same thing. Some plus minus 5%. That is the basic technique all the SMTs guys are following. Because if you ask them what is my load forecast, they said you see the last year's data and there is some increment and make plus minus 5%, so that will be my load profile. That is a standard technique in the load forecasting. And some people in case of solar forecasting, since the variability of solar is low, some people are taking this method, okay, to producing their solar power generation forecast. What is the numerical method? You have to calculate, basically simulate your different meteorological parameters using NWP models and forecast it. What is the physical approach? Basically, you have some sensors there, okay? You take those sensors, interpolate it or extrapolate it, okay, and get the statistics. And this is a simple statistical approach. Don't think anything. What data you have got, okay, make some correlation and say that, okay, it is over. It will be my forecast. And obviously, there is a mixed approach we are following there. We have some AI related approach. I don't want to go deep in that process. So just remove it. Okay. So we believe in one very simple sense. Okay, all models are wrong, but somebody is true, and we make useful models. Okay. Nobody can forecast. Simply, nobody can forecast with 100% accuracy in wind as well as solar. But you can make a model considering different the parameters of that solar plants, and it should be in plus minus 10% or plus minus 5%. So our model maximizes the energy accuracy, it minimizes the deviation penalty, but obviously we take a certain percentage of financial responsibility on if the penalty is very high to the right. So it is for the wind. I don't want to go wind. Okay. It is for solar. Okay, that is a one single revision. You will say, okay, just one revision is sufficient because my solar is there is no variable. Okay, just make a one revision. But in some cases, okay, in some plant, okay, sometimes the ramp is too much high that you need multiple type of revision, and that time you have to make some gain that how many times of revision, because revision has some cost. Okay, if it is not in accuracy, okay, then I have some penalty. So you have to make some gain that how many revision I will do, depending on how much accuracy I can give to IBBs. It is in that Karnataka plant, okay, and in case of the penalty is coming nearly 0.83% of the revenue. And it is an interesting case because this plant has no historical data. It is a new plant in 10 megawatt Pangara plant. The only thing affects in solar is the rainy season or the monsoon season and the normal season. In what we have done in our analysis in the last 1 or 2 years, okay, in normal season our penalty as a percentage of revenue is less than 0.05% less than, and in case of rainy season it is around 0.5 to 0.75%. Max case it comes in 1.5% in case of one plant. It is just example in one plant in 25 megawatt plant in Rajgarh. Okay, another is Gujarat. It is a very old plant, and it is okay. And that is our accuracy is the revision of the wind and the forecast. And we are getting nearly 98.69% of accuracy, and it is quite good what we are saying, because we are trying for the 99%. Obviously, we cannot go for the 100%. And thank you. Any questions? Yes.
Hi, good morning. You talked about different states having difference in the threshold margins for forecasting and its adaptability in terms of how it's changing over a period of time. Recently, the new thresholds of 5% and 10% introduced by I think Tamil Nadu or
Tamil Nadu is a 5%, Gujarat is 8%.
8%. Do Do you think this is doable?
In-
Your comments on those?
Yeah, the
features?
thing is that up to 2.5% we can go till our system is ready.
But is it all tested across different
Different location.
different location? No, location is fine. but in
Different
terms of
location and different season.
season as well,
Season,
because
yeah.
it's in monsoon. I'm pretty sure that it's going to be like
No,
varying
but
ridiculously.
it can go up to 2.5% if the at least 2 months historical data is ready. Okay. But in the most of the solar plants, we don't have the historical data. That is the biggest problem now. Unless we are, that's like Gujarat regulation. They said that presently it is 8%, but every year it will reduce in 1%. So it will start this next year. It will be 7% plus.